Welcome to Syntax. On this Monday hasty treat, we're going to be once again talking about the thing that we all hold so dearly. In fact, we hold it for a long time. Sometimes we hold it for days and days. I'm talking about caching. We're going to be talking about caching, but not necessarily in the ways that we've talked about it before. We're going to be talking about the Cache API, which many people think of as being part of service workers, but we're going to be talking about how we used it to build a Netflix-style save for offline for the application for podcast episodes on our Syntax site. My name is Scott Tolinsky. I'm a developer from Denver, and with me, as always, is Wes Boss.
Hey, I am really excited about this because I did not realize that this was the API that you needed to store stuff locally in the browser. I always thought it was like file system APIs or IndexedDB, and it turns out that there's a really nice cache API that's not just service worker. I've used it plenty of times in service workers, but not for storing data in the browser. And I've always wondered myself, like I would love to be able to, for my courses, like save them in the browser so people can watch them, but still get the whole streaming experience, you know?
Yeah, I know. The solutions I thought of for that at some point, because I thought about the same thing when I was doing level up tutorials, was I guess I'm going to have to make an Electron app, right? Making a desktop app. And then therefore they could download the course and then have it be easily work with the file system that way. Because the browser file system, if we haven't taken a look at that yet, in fact, maybe I should even pull that up here. Before we even get too deep into this, if you are listening on audio, we'll be showing some stuff on video here. I know I've said that a couple of times here, but I'll be pulling up API docs. I'll be showing some code. We're going to make the experience of the episode work just fine with audio as well. But I will be showing some things like this, like the file system API. And you can see with the file system API, browser support is not yet here. It works with Safari, works with Chrome, works with Edge, does not work with Firefox fully. Now, this is going to be the type of thing that's potentially going to throw an error in your system if you're trying to load up the file system API and it doesn't exist and you don't have permissions for it. And for something like that, you might want a tool like Sentry at sentry.io/syntax. Sign up and get 2 months for free, and it'll track and log all of the errors in your application. And that's going to be really handy if you're working with things like a cache, right? You don't know what you don't know if you're trying to save things. So why not use the file system API for storing this kind of thing? One, it doesn't work on every browser. Two, you do have to get permissions. And how, like, you click a thing to access the file system API. In fact, I did a whole course using the file system API, and it pops up saying, like, hey, the browser wants to access your local files. I think that can freak some people out.
It's kind of spooky when it happens.
Freaks me out, yeah. So, I think there is some reason there. I wanted this to just work transparently. Like, you hit a button, it saves to your system, that's it, right? So that's why I reached for the Cache API, which is, like you mentioned it being related to service workers. It's a part of the service worker API. And I think because of that, people don't realize that you don't have to use it within service workers. And in fact, somewhere in this mess on the MDN docs of paragraphs, it says, hey, just because this is a part of the service worker API does not mean you need to use it in service workers itself. It does need to be in a secure context, HTTPS, all that stuff. Not really super surprising there. But hey, man, what is the Cache API? It's basically a way for you to access and cache things in a request response way without having to do it via the browser cache or caching headers. You're essentially creating your own cache response directly in the browser. And it's really pretty simple. So we're going to be diving into how we pulled off what we pulled off on the Syntax site, maybe some gotchas, and then we're going to be talking even further about persistent storage and sizes of storage and those types of things. So first and foremost, like I said, Cache API, you can do a lot with this stuff. You can put anything in here. There is some caveats there in terms of size. So Chrome is probably the best for this because Chrome lets you store a percentage, typically 6 to 10% of the device's free space, meaning that if your device has 100 gigabytes free, you could store anywhere from 6 to 10 gigabytes, which is kind of wild compared to when you see some of the limits of some of these other ones, where Firefox has a global limit of 2 gigabytes for all storage API APIs combined. This is cache storage. It's any of the storage APIs on your browser.
Yeah,
right?
because there's lots of ways. There's lots of ways to store data in the browser, right? You have local storage, you have IndexedDB, you have what are the other ones?
Cookies.
I just sent you a whole list.
Is cookies kind of part of that? I guess that's not
Probably
really
not. Local storage,
that's a good
cache
point.
API, IndexedDB, service worker, and file system. So you talked about the file system API. We're talking about the cache API here. IndexedDB is kind of like local storage, but it's a bit more flexible for doing like full-blown database stuff. And then local storage is just a nice key value store. What I am curious about this cache API is that you said it's based on request and response, meaning that those are web requests and web response. And that's generally the way that works with a service worker, is that when the browser requests like a CSS file, you can write a service worker to jump in the middle there, and then you can say, oh, I've already stored this and send it on back because it's in the cache API. But when you're not in a service worker, that's primarily a fetch request, right?
Mm-hmm. The thing you need to think about this is that it is essentially the same API that you use with caching headers, right? You're caching things like normal. It goes into the browser cache, and that is a request response as well, right? You cache a font or you cache an image. When you pop open your network tab, you see that being loaded directly from the cache. But it's not like a key value store. It's the request and response. It just happens transparently behind the scenes. What this API allows you to do is just step in and store anything that you want in that same caching mechanism, which comes in handy for all kinds of things. You might be wondering why we don't just cache it via HTTP caching. I'll talk a little bit about that. But before we get off that, Safari only has a limit of 500 megabytes. Did I say bits? 500 megabytes per domain. And if it exceeds that limit, Safari will start removing items from the cache to make space for new data, which is one of the reasons why tools like Riverside that we used for recording, you can only use it in Chrome, because simply recording that much video is not going to work in Firefox or Safari, because you're going to hit those limits probably while you're recording, which that's no good, right?
Yeah, I was just looking at, I'm in the dev tools right now for Riverside as we're recording this, and they are sticking it in IndexedDB.
Yeah.
And you can see the little chunks. So there's an API in the browser called Media Recorder. Not sure if they're using Media Recorder or not, but the Get User Media will give you chunks of the user's video, and you can put those into the browser storage so that you can upload them as you have space to do so. And I was always curious what that looks like. And I guess the reason why they're using IndexedDB here instead of the cache API is because, like you said, cache API is only for request and response, right? It's not for, I made an image in the browser, or I have this canvas element that I want to be able to persist offline. And when I refresh, if it's not actually a request to a server, the cache API is not for that, right?
Yes. Yeah, and I think I wonder if I could have just done this in IndexedDB as well. Honestly, I don't know. But I think this was the best approach for me, and I'll talk a little bit about why.
I think so, because it's, at the end of the day, the MP3 for the show is a request, right?
Yes.
So it makes sense that you would save it.
Yeah, although the way I am accessing it, I kind of am accessing it like a key value store.
Let's talk real quick about eviction. That is when the data is gone, because you cannot promise that the data will be there forever. We'll talk about persistence in just a second, but eviction is when at some point your hard drive is going to get full. Between all of the origins, which is like a domain name on a browser, you're going to be using too much of the space. And there's only so much that Chrome can be allowed to use on your user's computer. And when you get close to that limit, the browser will just purge it for you. So I always like to think of these caches as, unfortunately, you can keep them there for fairly long, and it works fairly well. Like, we use Riverside, and I don't think ever we've lost a recording. Maybe once, but at a certain point, the browser will purge it, and you cannot guarantee that it will be there forever.
Yeah, I like to think of these things as like questionable storage. Not that it's questionable if it will work, but questionable if it will be there, right? You can put things in here, but you can't always assume that it's going to be there because, again, because of storage limits, how the different browsers work or time or any of that different. Maybe you open it up on one browser profile and another. So you can't always rely. You kind of have to take it as like, hey, I'm checking to make sure that the cache exists first before doing anything. So how exactly are we using it and what are we using it for? I mentioned a little bit about this. I'm going to show a quick demo here. I have the code open. I have our website open. If you're watching on YouTube, if you're watching on your podcast player, if not, I'll describe it basically. And I'm going to preface this is still in dev. This is the interface is not complete for this yet. So the way this works is that I have a little pin here in the player, and if I click the pin, it's downloading the MP3 right now, and it's downloading it and storing it as a blob. When it's completed, the pin kind of goes straight up and down. Again, UI is still being worked on here. But one thing that you'll notice happened is in my DevTools over here, which is in DevTools application cache storage, you'll see I have an MP3 cache here. And now, right over here, since that is completed, I have an MP3 cache where essentially the name of it is the request URL. So just syntax / and then an MP3. I chose this URL as a URL that's not going to be hit in the site necessarily. That's not too important. Either way, you can see when it was stored, the size of it, the response type, and if I click on it, yeah, there's no preview, but you do get the headers and stuff here. So now, if I were to go and play this file, if I head to my network and I click play episode, you can see that, where did that go? Where's the blob? Okay, so I filtered by media, and you can see that instead of trying to load this from Libsyn, which is where we host our MP3 files, you can see it's actually loading it directly from localhost as a blob here. So you can tell size is zero bytes because it's stayed in storage. You didn't have to download anything from the internet. So therefore, this is now officially loading this file from the local storage, not local storage, but from my caching API as a blob. So how do we do this in code? Well, it's actually pretty simple, okay? So when we go to save something offline, the first thing we do is we fetch the MP3 as we normally would, and when that comes back as a response, we grab the blob from it. So we don't grab JSON or whatever, it's an MP3, right? So we grab the blob. Then with that blob, what we're able to do is create a new response. Now I created a new response specifically to attach not only like content length here, but also metadata here. For some reason, I don't know if this is, maybe you can tell me why, Wes. When I was doing this without adding metadata and creating a new response and just using the response from the initial fetch, the content length was 0 for some reason. I had to do this manually. I'm not exactly sure why.
Oh, it's probably because it was pulling it from your browser's cache initially.
Yeah, it's interesting. I'm not quite sure why.
The whole response and like streaming thing is really funky. I was doing that with the Syntax website as well, where I had to I was trying to modify a response and Node was not letting me because I was trying to modify a header. So I essentially had to clone the response and then loop over every single header and add it in manually.
Yep.
Because it was kind of funky.
Yeah, so I had to create a new response, and I did so using the blob. I made it a content type of audio MPEG. Again, set the content length myself, and then the metadata header. What I did is I JSON stringified the entire object of the show data. Because what we do when we have the syntax player and you click play, it doesn't just load the MP3 file. It has the title, it has a link to the episode, it has share stuff. It has a lot of information in there. But if you're just doing a request and response to save an MP3, and if I was going to just cache that MP3 response without the metadata, it wouldn't have any of that. And then you'd click play, and yeah, you'd get the audio, but you wouldn't get all the other stuff. So I added the metadata header. I used the JSON stringify, threw all the show information in there. So that way, when we do load from cache, we can retrieve that information and load it up like normal. So to actually do the caching bit, since I've just created the response, all we did is we do caches, which is a global, .open, and then you give it a name. You'll notice MP3 cache was the exact same name that we saw in the Browser DevTools, when I looked at my application cache right here, it's the name that you're giving to this bucket. So by giving your information or your cache a name, you're essentially making a bucket. So once the cache is open, it returns a promise. So I do a then, and then I can do cache.put, where I then give it a URL, which is essentially the key of a key value, and the response, which is essentially the value of the key value, even though it is a request and response. It's a URL and a response. Not a request, so to say, but a URL and a response. That's it. That's really it. I can then, if you do cache.put, there's no async response there or anything like that. You can just be assured that it's in there, which is neat. It works really well. One thing that I had a little bit of trouble trying to do that I would like to try to do again, Wes, was streaming this. So that way I could get like a progress of how long, like where I'm at in the downloading into the cache process, because you can do that. And I had it working to a degree, but I was still kind of new to what I was doing. So I would like to try it again now that I have like a fully working implementation. I like pared it back a bit. You know, when you like work on something really foreign to you that you haven't done before, you try to do a lot of stuff and you're like, let me pull this back a little bit to the bare bones so I can get it working. So that's where I'm at right now. Okay, so this is the whole bit for saving it in the cache. Once you do this, whatever you're trying to save into the cache, you open, you put, it's in the cache. How do you get something from the cache manually instead of like having it be the browser's request for that thing? Well, I'll show you that now. It's within the player state here. So we wanted to have this work very transparently, where the user's not going to necessarily know if they're playing from local or not. So I wanted it to be a part of the normal play flow. And the normal play flow, again, is you click play, it loads up the data, it loads up the MP3, it saves it all to a Svelte writable, and then it opens up the player. We have a big old state object here. This might be the largest state object I've ever written in Svelte. So how do we load it from cache? The first thing we do is we open our cache of the same name. So MP3 cache returns a promise, you await that, then you have access to your actual cache. From there, all you have to do is a dot match with the string of the path, and it will give you a response. That's a normal response. With that normal response, what I did is I first got the metadata headers. I parsed it as JSON, and then I essentially returned it as part of the data. And then I replaced the URL of the data that the player is typically looking for with a URL created from the blob. You can do that with URL, create object URL, pass in the blob. That gives you a blob URL. Guess what? An audio player, you might not know this, you might. An audio player does not care if it's a .mp3 URL or a blob URL. It will play the audio as long as it's valid. So that's pretty much it. That's the whole process. So when you click play, it really quickly checks to make sure that something is in cache. If it's not in cache, gets out and plays the normal one. If it's in cache, loads it up, makes it into a blob URL, plays it in the audio player.
That's awesome. I was just looking up your streaming thing that you were asking about, and I remembered that we did a show on streaming, and when you want to both use a stream for something, like save it to the cache, and view the progress, you can't do two of those things at once, right? You're either saving it or you're viewing the actual progress. If you do want to see both of them, you have to use the .t method. And that will basically split the stream. In one of them, you can create a reader that will watch the progress. And then the other one you could probably just pass directly into the cache API. Although adding that metadata, it might get a little bit angry that you're trying to modify the headers before you put it in. That's probably the issue you had.
The metadata piece was interesting because I did think like, all right, here's another way I could do the metadata. I could toss it all in local storage and just with like a key of the same key as the cache. And then when I'm loading up the URL, I just that's very valid. I think I could have done that as well. I think this for me was just like, all right, I'll put it all in one spot and it'll be easy. So maybe alternate methods there you could do. But as you can see, I could store a couple of these. Boom, it loads pretty quick. I got faster net. And every time you save one, here, another one pops in.
Oh, that one. What's that issue you just got? I think that's related.
Failed to fetch MP3. Okay.
Headers.
Something might be wrong with that MP3 itself.
Oh,
I'm on a local build of the site here, so it's not guaranteed. Oh wow, another one failed to construct response. Contains an
string
ISO.
contains non-ISO code point.
Whoa. All right, I got some Googling to do. Like I said, this is still it's still in my development branch, but for generally it's working. At least the first two it worked. So I got some Googling to do about whatever this ISO code point is. I'm wondering if it has something to do with the file name. I don't know idea. Let's try this one. This is a pretty generic file. Yeah, this one's working. There we go.
It's probably, there's probably something in the show notes that is not a
stringifying
like
correctly.
Okay. Yeah. You're doing JSON.stringify of the show, and there's probably something in there. And if you're trying to set that to a header, you're trying to stick the entire show into a header as storage. It's probably, there's probably a weird character in there that it's not okay with.
Well, here's what I should do then, Wes. I should remove the show notes because we don't need the show notes for the player.
Yeah.
We really just need things like the show title and some metadata there. We don't need the show notes saved in there. So I got some work to do, so to say.
Yeah. But even then, if somebody's name has like an accented character in it, you're gonna hit that. So I'm trying to look at the show notes if they're what it could possibly be.
Well, these two, let's see, this one has a colon and this one has an ampersand, or let's see if this one has, I think a lot of them have colons, and I don't think the colon's the problem. So you're right, I bet it's something in the show notes itself.
You can either way encode it, but then you got all those problems as well.
Yep. So bugs to work out, but for the most part, I got 4 here saving, and it's working. You'll be able to very soon, and I'm going to say by the time you're listening to this episode, this interface will be tweaked, and this will be available for you. But you'll be able to store this files locally on your computer to play offline or your phone or whatever.
What about if like we had something where you went to the shows and there was a filter for offline saved? Are you able to pull out and like loop over and show those, or how does that work?
Let's check the cache
keys.
API. I would imagine you do keys here. I'm not positive. I have not thought about that, but keys. Yeah, you open, you get the keys. Hey, bingo bango, Wes. That's it.
Yeah, nice.
Yeah, so we'll be able to do that for sure. Another thing I'm going to be working on in the same regard is like queuing. So if you add an episode to the queue, I'm going to have it automatically saved to your cache. So that way, it's like preloading essentially for MP3 files. Pretty neat.
Awesome. One last thing we want to talk about is just persistent storage. So I was always curious about this as to when does it get sort of pushed out. And we talked about the browser. Once it gets full, it starts to sort of purge. And I found some interesting stuff online about this. I'm just going to read through it. It says, each origin gets a higher storage limit. By default, the browser will evict data by origin, which is a domain name. When the total usage of all origins is bigger than a certain value, the overall quota is calculated based on disk space. So again, it says, all right, well, now Chrome is taking too much of disk space. Like, what do I do about that? However, at that point, the browser says, all right, what do I delete? Do I just start deleting random stuff? Because some of it will be, you cached a CSS file. It's fine. We'll just go download that again. And some of it will be more important stuff like, oh yeah, I saved a recording that hasn't uploaded to the cloud yet, and the only place it exists is in the browser cache right now. So that's pretty important, right? So there's an API called navigator.storage is the API that will allow you to see how much space is available for you to store stuff. And navigator.storage.persist is the API that will it used to like pop up a thing and says, hey, can we store stuff in Chrome? Yeah. And now it's just based on flags, like how often you visited the website, if you've bookmarked it. There's all these things. Kind of the same idea of when you want to autoplay video.
That's what I was going to say.
You're not allowed to autoplay video unless the user has interacted with the website a whole bunch. There's like a whole bunch of stuff that goes into calculating the score of a website. So I had now you can just say navigator.storage.persist, and it's kind of like a pretty please can we have elevated storage, like don't delete us first, please. It doesn't pop anything open, and it simply was return true or false. So I ran it on Chrome on Riverside, and it returned true. But why? Because I'm here often. I spend a lot of time on this website. I interact with the website. I've bookmarked it. And then I tried it on a website I've never been to, and it obviously says no automatically. So I don't know what those flags are by browser. I think it's up to the browser to decide what is important and what is not. But I thought that was kind of interesting.
If that feels mysterious, let me tell you, as somebody who's had to maintain an autoplay feature on a website, man, that is one annoying system to work into, because you'll think that you have it working. It works for you. It works for most people. And then you'll get GitHub error. Autoplay does not do anything. I'm like, okay, great. How am I supposed to debug this when it's not like it's throwing an error or anything? It could just be that they have not interacted with the site enough. And like the one thing is that the user has to interact with the site before autoplay works. I wonder how much, like Google, I'm not like trying to do any conspiracy thinking here, but like YouTube has no problems with autoplay. Is that because YouTube and Chrome are owned by the same company?
No,
I have no idea.
You can look it up. It's called Media Score. Let me find it. Chrome
How do you look it up?
All right, so I'm in Chrome /media-engagement, and this will actually give you the information about how much your user has interacted with it, and it will give you whether it is a high media engagement score or not. And you have a high media engagement score, and that is one of the ways that you're allowed to autoplay videos. So look at this. YouTube, 16 sessions, 6 of them I actually played something. Last time I played something was January 1st, just because I don't use Chrome for anything other than recording this podcast. And then but it is a high media engagement score, right? And then all of these other websites here are just like domains or origins that I have interacted with, and it has a low media engagement score. I'm kind of curious if I look it up. I switched to Microsoft Edge.
This still kind of makes me annoyed that this exists. Like, how am I going to debug somebody else's, right? Like a user says, I have my autoplay doesn't work.
You can catch the error. So a play method has switched to a promise. So what you can do is you say await video.play or audio.play. And if you're not allowed to play, you catch it. So just put a .catch on the end, and then you can say, oh, it's not done. And yet the real trick though is you just listen for any click at all on the website and play something at that point, and then you're in.
I hate that. I hate all of this because like somebody comes to me and they say, hey, I clicked the toggle that says autoplay. Your videos don't autoplay. The site's broken. Like I got to send an email or I got to send a response or, catch that or whatever at the moment and say, oh, you haven't engaged enough with the site for autoplay to work, even though you clicked the toggle that said, please let me autoplay. Like, there has to be a better permissions model than this. Yeah, but give me just a straight up permissions flag.
But once you click the button that turns on autoplay, there's your click.
Yeah, but what if they refresh the page?
What if they refresh?
The toggle still doesn't work.
Then they have, well, no, that's a good point. I tested it when I was doing my autoplay, and it was very easy to get a high enough media engagement score. I think the user had to watch a couple minutes.
But even with like a high enough engagement score, upon loading a page, the browser still doesn't like it to immediately start playing media when a page has been opened without some sort of click or some sort of anything.
No, you can do it if your media engagement score is high enough.
No, I know, but it doesn't like it. I'm telling you.
Who doesn't like it? The browser?
The browser gets angry. It says, no, thank you. Yeah.
No. You're wrong about that. As long as your media engagement score is higher, and I'm reading it right now, consumption of media must be greater than 7 seconds. So as long as you can play something for 7 seconds that is in unmuted state, you could do that. And I bet you could get around that by playing.
Give me a permission flag. Just give
nothing.
me a yes. Give me a yes or no. Come on.
Yeah, it's true. Are you going to allow this? Because honestly, there's most websites I don't want autoplay on unless it is actually a video website like YouTube or my course platform.
And guess what? I'm a big boy. If that pops up and says, would you like this site to autoplay video? I click no and feel good about that. I don't want the browser making choices for me about which sites I can autoplay video on.
That's true. I think also people hate that though, because
another pop-up.
With permissions, like you see this on iOS all the time, they pop a permission up and they try to do like a fake permission, because if you're going to click no, they don't want to show you the real one, because then you got to tell the user how to go into your settings and turn it off. Like once they hit no, it's over. There's normal people are not turning that setting back on.
Yep. Man, no fun stuff, huh?
Permissions is a hard thing. Yeah. All right. I think that's good enough for today. Hopefully you enjoyed that. We will catch you later.
Peace.
Peace.